This problem is about phase transitions. Please read the problem, understand the question, propose a solution, and after a few minutes, let's compare our answers. In order to solve this problem, the first step would be to calculate the number of grams of ethanol. Because there are several steps involved going from gas to liquid, we will need to calculate the heat involved in each of the different steps. These are, first, the heat released to cool the vapor to its boiling point. Second, we're going to calculate the heat released upon condensation to liquid. Then we will calculate the heat released to cool the liquid to 25 degrees Celsius. And then we'll add all the heats involved in each of the different steps. So let's begin then by calculating the number of grams of ethanol. So the problem states that we have 0.333 moles of ethanol, abbreviated as ETOH. And we are going to multiply that then by the molecular mass of ethanol, 4607 grams per mole of ethanol, and that gives 15.34 grams of ethanol. Then we're going to calculate the heat in each of the different steps. The first step will be from vapor to the boiling point. Q for this process or this part is going to be the specific capacity of the gas multiplied by the mass multiplied by delta T. The problem tells us that the heat capacity is 1.43 joules per gram degree Celsius. We want to multiply that by the mass, which is 15.34 grams, and then delta T, which is 78.5 minus 300. Altogether, this gives for Q1 minus 4,859 joules. It's negative because heat is being released as the vapor is cooling down. The second step is condensation. So of condensation, we are basically transferring everything from the gas to liquid. And this is going to be represented as Q2. And we're going to multiply then the number of moles. We have to work in moles in this case, times delta H of condensation, and that is going to be equal to 0.333 moles times minus 40.5 kilojoules per mole, and we're going to have a factor for this, which is to convert everything to joules, 10 to the 3 joules per kilojoule. And that gives a value of minus 13,486.5 joules. Again, we are releasing heat as the gas is condensing into a liquid. The third step is cooling the liquid. So here we're going to have cooling, and that's going to be in the liquid phase. So, and that's the final temperature to keep in mind is going to be 25 degrees Celsius. So it's going to be very similar to Q1, but this is Q3. We're going to have the heat capacity of the liquid. Then we're going to multiply that by the mass, and then multiply by the delta T corresponding to this step. And this is going to be equal then to 2.45. I will skip writing the dimensions because they are similar to Q1, times 15.34 times the delta T, which is 25 minus 78.5, which is the boiling point of ethanol. And the net result of this calculation is minus 2010.86 joules. So what is left to do is going to be calculate Q total, which is going to be equal to Q1 plus Q2 plus Q3. If we replace the values that we had from above, plus minus 13,486 plus minus 2010 is going to give us minus 20356 joules, which is equal to 2.04 times 10 to the 4th joules. And this is the answer of this problem.